Problem 3.6.14. So we're supposed to create a polynomial, degree 4, so it's got to have either 4 linear factors, or if you multiply it out, it'd have a highest exponent of like x to the 4th. There's supposed to be a negative 3, multiplicity 2, and then this one complex 0. So what you need to know here is that since this polynomial is real, that if you've got the x minus like this 2 minus 3i as one of your factors, so that would be like x minus, if you put that 2 inside, plus 3i as your factor, but then you also have to have the conjugate that goes with that as a factor as well. So like the 2 plus 3i, so you'd have an x minus 2 plus 3i. When you have those conjugates, reminder that when you multiply them together, that like the 2 minus 3i and the 2 plus 3i, that's what turns it back into real, because those imaginary parts there cancel out with the minus 6i and the plus 6i. The minus 9i squared from here, that's okay, because I squared is negative 1, so minus 9 times negative 1, that's just turning it back into a positive 9. So these guys have to travel in pairs, the conjugates, if it's going to be a real polynomial. So we've got our x minus 2 plus 3i, and we've got our x minus 2 minus 3i for our, those multiply out. And then we have a negative 3, so that's like x plus 3, but a multiplicity of 2, that means there's a 2 right there. So we've got degree 4. This one would be like an x squared because of that 2 times this x and times that x. And so type an expression using x as the variable, use integers or fractions. And it says simplify, so that usually means you're supposed to multiply this out. So if we continued over here with these, this would be like a 4 plus 9 here. So this part out here, this is kind of gross to have to multiply this out, but x squared plus 6x plus 9. And then if you multiply these two out, I'm going to put it in a big box to keep stuff organized here. X minus 2 plus 3i, x minus 2 minus 3i. The real thing we want to make sure is that our i's all cancel out here. So where would we have our regular i's here? We'd have a negative 2 times this 3i here to be a negative 6i, and then negative 2 times this negative 3i here would be a positive 6i. But I'd also have this 3xi in this spot, and then where's the other one? And this one would be a negative 3xi in that spot. So those do seem like they're all canceling out, so that's good, right? Those two wipe each other out. These two do negative 3i times 3i, just like we were talking about over here. So that's going to end up being your negative 9, right? Negative 9 times I squared is a positive 9, because I squared is negative 1. And then in here we've got a 4, we've got a negative 2x there, a negative 2x there. You might find a better, faster way to do this, but I'll just write it out this way so everybody can see it. So then we've got x squared minus 4x from these, and then this 4 and 9 is a 13 from there. And then we still have to multiply this one out. Now some books don't require you to do that. They accept if you just leave it in this form. But I have a feeling from some of the other problems we've seen in this book that unless you multiply this all the way out, you're not going to get credit here. So you're going to have to, you know, I would normally say I'll probably do another rectangle for this to make sure I don't make a mistake in there. You've got your x squared plus 6x and a 9, and then you've also got on the other side an x squared of minus 4x, and a 13. And so multiplying all those together, you got an x to the 4th there, a negative 4x to the 3rd there, 13x squared there, 6x cubed here, a negative 24x squared there, and a 6 times 13, I think that's 78. And then you've got a 9x squared, and you've got your negative 36x there, and 9 times 13, I want to say that's like 117. But then combine your like terms. I think we've had this before where our diagonals have the like terms. So our x cubes there would combine, our x squareds here would combine, and then our x's would combine to get us our final answer for the problem that I was given here. Just in case I messed any of those up, 9 times 13, I wanted to just double check that. 9 times 13, 117. The other one was the 6 times 13, 78. Okay, so that's all good. And long as I didn't make a mistake anywhere else, but hopefully you at least get the general idea. So I've got the x to the 4th, the 6x cubed, and negative 4, that'd be 2x cubes. Then those other diagonals with the x squareds. 9 and 13 is 22, and a negative 24 would cancel out all of them but 2. And then those 36 and 78, that looks like about 42 extra positives. I think 42 added onto this, so yeah, that would make that 78, and the 117. So I think they're going to require you to enter all that. If you just make a mistake in one of these parts of where you were distributing out, the key here was, again, these conjugates have to go in pairs like that so that the imaginary part cancels out when you expand it, like we saw down here. So when that canceled out the i's to turn it back into a real polynomial, degree 4. Problem 3.6.14.